Good morning, students. I am Manikant Mishra, Modern English School, New Area. So in a previous video, we are discussing about the chemical properties of acid. So today we are going to continue to discuss the chemical properties of an acid. In this regard, next chemical properties of an acid, a reaction between acid and metal oxide. Reaction between acid and metal oxide. Metal oxide reacts with acid, forms salt and water. When metal oxide reacts with acid, forms salt and water. As for example, sodium oxide reacts with dilute sulfuric acid, form sodium sulfate and water. So corresponding metal, salt and water are formed. Similarly, this copper oxide, which is a black in color, when it reacts with dilute sulfuric acid, forms blue color of copper sulfate and water. Magnesium oxide reacts with the hydrochloric acid, forms MgCl2 and water. So with this experiment also we can conclude the metal oxide reaction between metal oxide and acid are also an example of a neutralization reaction, and metallic oxide, whereas metallic oxide act as a base, due to which base reacts with acid, forms salt and water. Now next chemical properties of acid, reaction between metal sulfide and bisulfite. Metal sulfide reacts with the hydrochloric acid, evolves sulfur dioxide gas. Metal sulfide or bisulfite reacts with acid, evolves sulfur dioxide gas. Like a calcium sulfide reacts with the hydrochloric acid, evolves calcium chloride, water and sulfur dioxide. Sodium bisulfite, or also it is called sodium hydrogen sulfide, reacts with acid, forms sodium sulfate, water and sulfur dioxide. One more chemical property we can add here, like a metal sulfide reacts with metal sulfide reacts with acid, evolves hydrogen sulfide gas. Reaction between metal sulfide and acid evolves hydrogen sulfide gas. As for example, FeS plus H2SO4 forms FeSO4 plus H2S. So metal sulfide reacts with acid, evolves a hydrogen sulfide gas. With this the chemical properties of acid gets over. Now we will discuss the next topic, that role of water in acid to show acidic character. Or on the other hand, we often come to know that acid do not show acidic character in the absence of water. So let us confirm whether the acid can show its acidic behavior in the absence of water or in the presence of water. So in a test tube, take a test tube. In a test tube, you take a few solid crystals of sodium chloride and add little amount of dilute sulfuric acid. As you add the dilute sulfuric acid, you will observe that a gas starts to evolve. Now you bring the dry litmus paper near the dry blue litmus paper near the mouth of the test tube. Then you will observe that the dry blue litmus color remains blue itself. So it means the gas, HCl gas is evolved, is unable to show its acidic character. Now you bring the moist blue litmus paper. Now you bring near the mouth of the test tube moist blue litmus paper. Then you will find that the blue litmus color change into red. So it means the acid can show its acidic character only in the presence of water. So it means here we can say the HCl will dissociate into ion. HCl gas dissociate into their constituent ions H plus and Cl minus only in the presence of water. HCl gas dissociate into H plus aqueous only in the presence of water. So water is a very important role in order to decide its acidic character. In order to show its acidic character, there must be presence of water. Otherwise, no any acid which is in the gaseous state will show its acidic character. So based on this, the Arrhenius, 70 Arrhenius. So according to Arrhenius, acids are that substance which dissociate in aqueous solution in the form of H plus ion is called acid. According to Arrhenius, acids are that substance which dissociate in aqueous solution or in a solution and gives H plus ion. So HCl plus H2O, H plus aqueous plus Cl minus aqueous, H2SO4 plus H2O, 2H plus aqueous plus SO4 2 minus aqueous. So according to Arrhenius, acids are that substances which dissociate in solution and gives hydrogen ion. So HCl plus H2O gives H plus aqueous plus Cl minus aqueous. H2SO4 plus H2O gives twice H plus aqueous plus SO4 2 minus aqueous. Now, but as we know that the H plus, the radius of H plus ion, the radius of H plus ion, radius of H plus ion is equal to 10 to the power minus 15 meter. The radius of hydrogen ion is very extremely small in size, 10 to the power minus 15 meter, and intense electrical charge, and it has intense electrical charge due to which it does not exist. Immediate it combines with water. It combines with water and gives H3O plus H3O plus. So instead of saying the acids are that substance which dissociate in solution or gives H plus, rather we should say H3O plus. So acids are that substance which when dissolved in water produces hydronium ion. Acids are that substance which produces hydronium ion in their aqueous solution. So once again, acids are that substance which produces hydronium ion in their aqueous solution, not H plus ion, because due to very small size and intense electrical charge, H plus immediate it combines with water and produces or forms H3O plus. Now if you notice it that HCl plus water, H plus or H3O plus, so single headed arrow is pointing towards the product. Here two types are there. One is a single headed arrow pointing towards the product, another one is a double headed arrow. So what does it mean? The chemical reaction in which acid dissolve in water and produces H3O plus pointing towards the arrowhead, pointing towards the product, it means all the acid dissociate into hydronium ion. Acid which completely dissolve in water in the form of hydronium ion is called strong acid. It is denoted by single headed arrow. So example is HCl, H2SO4, HNO3 is called strong acid. All the acid which when dissolved in water completely dissociated in the form of H plus ion or H3O plus ion, such acid is called strong acid. On the other hand, acid which when dissolved in water, dissociate partially in the form of H3O plus is called weak acid. Example, CH3COOH plus H2O, either you can write X plus or also you can change H3O plus. HCl, H plus or H3O plus. So here it is represented by double headed arrow. It means some of the acetic acid, some of the hydrogen cyanide dissociate into ion, some remain as a molecules. Some remain as a molecule in the form of acetic acid, in the form of hydrogen cyanide. Some of the compound only dissociate into hydrogen ion or hydronium ion and acetate ion. Hydrogen cyanide dissociate into hydrogen ion or hydronium ion and cyanide ion. So if the acid when it is dissolved in water, dissociated partially, then it is called weak acid. So strong acid has a large number of hydrogen ion or hydronium ion. Strong acid has a large number of hydrogen ion or hydronium ion. So it means it has a large number of ion, so it acts as a strong electrolyte. So strong acid acts as a strong electrolyte. And since weak acid has a less number of hydronium ion or hydrogen ion in their solution, so they act as a weak electrolyte. So they act as a weak electrolyte. Thank you. Have a nice day.